second edition of Natural Language Processing in Action, and I'll in fact show a diagram from it today. Today I'm going to be talking about Reflect-A-Bot. This is a project to train the therapists who are sort of train the trainer, basically. And there's a third layer of training because, of course, you've got to train a bot to machine learning algorithm to do the training of the trainer. So the therapist training bot is trying to encourage this thing called reflection. You'll know more about reflection than you ever wanted to know. It's not what you think. It's not like reflecting in a mirror. This is based on research by Nen et al. And Perez Rosas et al. And I'll put that link to the slides on the there we go. So I'll talk about the purpose of the project, the theory of impact. You may not have heard of that term, but I'll explain it. How we're going to measure progress, how we're going to measure the measurer, which is the machine learning algorithm, and then how we're the kind of data you need to accomplish that, the architecture, how you use that, and I don't think I'm going to get to the data science process, and I'll just verbally talk about the preliminary results. And I can show you a monkey patched IPython that gives you more access to more magic commands in Bash. I don't know if any of you have been looking for grep and more and some of the other Bash commands from within Python, but this quick little easy patch makes that possible. The purpose, we want to improve the quality of counseling sessions. So of course we want to improve the mental health of clients, of therapists. These are therapists that are in training at UNC, Chapel Hill, I think, and which is where Joe Crowder, who sponsored this work, is based. He's moved back from San Diego to North Carolina. So the three things we're trying to deal with, the professors are overworked, it takes a lot of time to do these interviews, and obviously therapy is a very interactive thing that requires a lot of practice. The professors are overworked in doing those one-on-one conversations. You can imagine, you can't just do a lecture and expect the material to be grokked. Students do not get enough practice. That one-on-one practice is really critical, and the practice that they do get, when you have a professor doing it, this is not what the professor said, but this is what I'm inferring, is that I can imagine it can be quite rote. They probably have a script. They're pretending to be someone with a mental health issue, and so they probably don't, the students don't probably get as much variety as they might through some other system. That can bring in a more diverse set of not only demographics in terms of the voice, but also in terms of mental health issues. The theory of impact, that better training will equal better counselors. And that automation will solve all of these problems. Reduce the workload, allow students to practice more, motivate students to practice more, and create more diverse practice sessions. So in any kind of nonprofit work, you're always looking for your theory of impact, so that you can go to your donors and say, this is what we think we're going to do, and this is how much money we need. And so this is typically the kinds of things you would present to your donors. Or for a university, this would be like an NSF grant that you're proposing. The metric, so you need to measure now how well you did on those things you're trying to impact. In the scientific method in education there are two kinds of assessments you can do of the effectiveness of your education. One called is summative assessments. This is the most common one. This would be like taking an exam. It sums up all of your knowledge and assesses it typically at the end of a course. And the scientific method, which is rarely done in any kind of education course that I'm familiar with, would do that summative assessment at the beginning of the course and then again at the end. Similar to what the Art Prize is doing, especially Art Prize 2, which is trying to test the learning ability of machine learning algorithms. But if you're interested in Art Prize, I can talk about it forever. Data science is the key here. We're going to use the data science method. We're going to try to run these metrics online in real time. So we're doing, instead of summative assessments at one time at the end of the course to give you your final grade, we're going to do it online, real time, which is called formative assessments. So at the same time you're doing education, you're also measuring the quality of the absorption of that material, the understanding, basically, of your students. Typical ways of doing formative assessment is practicing in a simulation, like the coding environments for Python and Runestone Academy, an online free open source tool for teaching Python. It's a textbook. It's an interactive textbook where you can actually run code. Spaced repetition, things like Anki, that's another form of formative assessment where they'll count up how many things you missed and send you the ones that you are about to forget by estimating when you're about to forget them. Great for memorization sort of tasks like learning languages. And the most recent and powerful tool for formative assessment, of course, is gamification. Make it a game, make it fun, such as tools like Libra, Lingo, and you know of the commercial alternative to that. Reflectabot is going to, so a Reflectabot is our attempt to do formative assessment and training at the same time. Whenever you're doing a data science project, especially if it involves mental health in general, or medicine, you need to identify your positive class. It's not what you think. It's not a good thing. The positive class is typically a disease, because you're trying to minimize the likelihood of that disease. And so in this case, the disease that we're trying to prevent is anything other than reflective counseling. So reflection is when the counselor reflects back to you your emotions. And this is not only a good skill for the counselor or the therapist, but it's also a good skill for the client. Whenever you are feeling strong negative emotions, it's very good to reflect on those emotions and repeat them back to yourself. Give them a label. I'm feeling, not say I'm depressed, but say I'm feeling anxious about X, or give it more, try to give it a label so that then you can go back to your memory banks and say, oh, the last time I was anxious, something that helped was X. There's two other labels that we have in our data set, complex. So sometimes therapists will go into much more detail or reflect on many different aspects of the conversation that they're having, and that's called a complex reflection. It's too much information. It's typically not effective. Another bad one in our negative class, or our positive class, is the other, everything else. If they're talking about anything else other than doing a good reflection, then we're marking that as bad. Now we need to grade it. So we're going to have a classifier. In machine learning, you give it a bunch of examples of good stuff, bad stuff, and you give it labels. And I'll show you an example of that data set. As with rulers, sometimes the different rulers will make mistakes. So we're using a ruler to measure the quality of the education. We need something to measure that ruler. And here you can see that the metal ruler in the middle, the pink one, is measuring slightly different length of an inch. If you look really closely, it's a 1/16 of an inch off for every 4 inches in the wooden ruler. So we've got to be very careful about that. But that's just a side note. The thing we're looking at here is how we measure the quality of the accuracy of our bot, or the performance of our model. And in data science, we talk about models. Models are trying to predict something. In this case, we're trying to predict what the natural language means coming out of the counselor, whether it was good or bad. And so we can look at the accuracy. How many times did they do reflection? We could look at recall, which is actually how many times did we label it as reflection when it was indeed reflection in our test set, versus, and also how many times did we identify it as not reflection and got that right. So the number of correct over the number of incorrect. It's like a true-false test. And that's what accuracy means. It's like a grade on a true-false test. However, recall and precision are often used in particular cases, especially in medicine. They're really important to know in medicine. So this is the false negative or the false positive. When you accidentally identify a disease when you shouldn't, that's a false positive. And when you accidentally declare the person clear and clean, so this would be, in this case, this would be a reflective statement when it actually isn't. So you often want to look at those two, but if you want a single number to put those two together, you can use one of two things, either F1 score or AUC. Area under the curve, I won't go into that, but that's probably the best one because it doesn't rely on you actually making a threshold on that assessment. If you have a continuous value like the probability that it's reflection, AUC gets really, really good estimate of how good your model is, and it gives you a lot more information than F1 score, but F1 score is a nice balance between, it's the geometric mean of recall and accuracy. You can remember what recall is just quickly, because it's like in a search engine, the recall rate is the number of times that the pages, that it's going to find all of the pages that have the words in it that you're looking for. So it's recalling. It's recalling from its database, and if you miss any of them, that's a mark against recall. Precision's the other way around, and it's just a good way, you can remember it that way. It's an easy way to remember this, because false positive, false negative, it gets hard to remember those rates. If you're interested in machine learning, a little mnemonic for you. So what kind of data sets do we have? We have several of these complex reflections, complex 0, complex 1, that's just whether it happens in the first statement or the second statement from the counselor. And we have these others, which are also bad. And we have the simple reflections, which are the ones we want. In the real world, so we ran a quick test. As you can imagine, people like Job and others who don't have a lot of experience doing an LP or they've had a long, prosperous career doing software development, and they see LLMs being able to do everything they ask them to do in terms of natural language processing. So let's just throw it at an LLM. Let's tell it to pretend to be someone suffering from depression, and then have them talk to a student and see, actually have them talk to the professor in this case, pretending to be someone who's learning about therapy, and see how well it does at responding appropriately to the therapy given by the counselor. So in this case, it did pretty poorly. The initial feedback I got from Joe and the professor was, it was all crap. The bot was not keeping track of the context. It just got more and more angry about, it was not, so the counselor asked about, just did a really good, simple reflection of, let's see, I can't recall, I'm pretty sure, the counselor, so that first one is, so here's an example of some good reflection. Oops, don't want to do that. Sorry. So you want to, this line 6, or 0 offset from line 6, is an example of a good reflection. And you can see that some of the others were labeled, like the question that was given by the counselor was bad. So I guess this was a student because they got it pretty bad. But, and the bot was also not helpful as well in steering the counselor in the correct direction, because they weren't responding whenever the counselor did good things. And so that's a problem that we're trying to solve by recognizing when the reflection happens more and more angry, more and more depressed. We're trying to show that progress to the counselor so that they get positive feedback. And so we need to classify the correct behavior of the counselor in order to steer and prompt the LLM to generate more appropriate content. This is a well-known problem. LLMs cannot reason. They're only predicting the next token. They're really great at just continuing whatever prompt you give it and continuing on and making that sound plausible. So it's really up to us to put that prompt in there correctly. If there's any reasoning that's required in there, and obviously mental health requires a lot of reasoning especially in responding in a coherent way to logical information from a counselor. The only way you can accomplish that is through conventional natural language processing and hard-coded rules built upon conventional approaches. So this is the approach that you would see in the textbooks, and this is the approach that I put in my textbook. It's a little more detailed than you might see in most textbooks, but at the top you have bot text messages, and that goes out to the human responds, and then the very first thing you do is you try to understand. That's called NLU, so that's a natural language understanding. You try to understand before you decide what to do with that. There's a lot of different ways to understand. Deep learning is probably the one you're most familiar with. There's also information extractors, so if you want to extract names or people or places, if you want to actually do some logic on objects in the real world, you're going to want to do information extraction and compare that to a knowledge graph. This is what Google did with their knowledge graph in their Google search before they decided ads were more important than actual truth. And then grammar and regex, that's also a very, very good way. If you have something that needs to be spelled exactly correctly or approximately correctly, if it's a name, regexes it's a tried and true method for extracting strings. And you need to combine all of those. Once you've done a classification like we're doing here on that, then you can go to the conversation manager. This is where the logic happens. This is when you say, if the person's getting angry, then you try to defuse it. Or you, instead of mirroring that anger yourself, you do something else. So that's where all the magic happens, and the logic and the reasoning. It needs to happen in another part of the brain besides the natural language model. That's all these things are. LLMs, chatbots. When I say LLM, I'm talking about ChatGPT, Claude, any of the large language models out there that you're familiar with. And they do not have anything other than a language part of their brain. And if you think they're doing anything besides bullshitting you, they're doing a really good job bullshitting you, because they're equivalent to all of the bullshitters on the internet working simultaneously together and getting the best one who's ever said any bullshit in response to somebody's question. They're getting that response and they're blending it with all the others and giving it back to you. But it has no reasoning. It has no logical center. It can't do math, it can't do counting, it can't do geometric reasoning. They're finally waking up to that, 4 years into it, and tens of billions of dollars later. They're waking up to that, and now the new reasoning models have a whole other system that monitors the conversation and has it try many, many, many different things and uses many, many different tools and tries to find the right tool. They're still going about it the wrong way, but they'll eventually catch on to it. And things like the ARC Prize will help them find the correct way to do reasoning. I'm running out of time. Let's see. So after you've done the NLU, finally you can do the generation. And this can be through templates, and I'll show you how we're doing that in our case. You can then pass those templates to another generative model, or you can go straight to an LLM if you'd like. That's where generative models like LLMs are great. They do perfectly grammatically correct. They match the sentiment you asked for. They can match the tone. They can match any person's personality that appears in text. They're really, really good at generating text, as long as you tell them the kind of text you want to generate. Reflective bot. In our system, it's much simpler. Of course, we had this. It started out with just these top 3 boxes. So the start box going into the application. This is a mobile app on your phone built in Flutter, and then it goes into an LLM, which is typically ChatGPT or some open router system that's going to automatically select one. And then it goes to the counselor, that statement like, I start a diet in the morning, but I get hungry and lose discipline. This is from an actual paper with a study that they did. And the counselor can then reply poorly with, discipline must be paramount. Try to control yourself. It all depends on you. That's not the appropriate reflection technique. Instead, they should have said something like, you really struggle with sticking to your weight loss goals when you're hungry. That's reflecting the statement and the logic of what the other person was saying. And then, so now we've added this bottom layer. I've just recently added it this week. So they just brought me in last week. And so I'm adding this additional piece, which is just a natural language processing classifier. We're sending these 3 pieces of information. Of course, they only need the classification label, and then from that, we will just adjust these other steps over here in the application. Which LLM are we going to use? Some of them are better for handling particular situations than others. In my experience, the simpler the LLM, the better, because it's less likely to muddy the waters. It's going to be more predictable. You're going to always want to set the temperature to 0, so that way it always does the same thing if you set it the same prompt. And you're going to want to put in things like your template's going to have something, pretend to be someone with, and we could also classify some of the information. We could also choose from a list of mental health issues and details about those health issues and plug them into a typical F string in Python before we send it off to the LLM. And someone could be some particular demographic, so we're going to choose from that. And of course, if we're having a consistent dialogue, we want those things to be the same throughout the conversation, and the only things we're going to affect will be the details of that in order to reduce that poor mental health thing. We're gonna gradually reduce the severity of their mental health issue as the counselor does appropriate things, and we'll dial it up when they do the wrong things, so that the human will appear to react as a real human. The bot will appear to react like a human would. In theory, this should be easier than trying to mimic an actual counselor bot, try to have all of the detailed tools, but as we know from the 1960s experiment with ELIZA, it actually can be quite easy to do this well as just a regular expression. So we may find that some of those old techniques will end up being better than LLMs. They tend to be less controllable. But anyway, I'm going to help them use an LLM because that's what they want to do. Just links to the paper. Questions? Yes?
Just going back a slide, forward one. So like a counselor basically is restating the question and like basically restating that. So it sounds kind of similar to that like chain of thought reasoning. Like you have you see the new LLM architectures, you give it a prompt and then it responds and sort of rewords it and has those like, thinking tokens, and then it gives you the response after. So how is this different?
Well, that's exactly what we're using.
Okay.
We're using, it's just the chain of thought reasoning is telling it to do this, prompting it in a similar way to the way we're prompting it. We're just not telling it, give me all of the steps to accomplish a goal, which is chain of thought reasoning, supposed reasoning. It's not reasoning, by the way.
Next token.
Predictor,
yeah.
But so we're making it simpler. Just give us well, it's not going to work well because I'm not in favor of this approach. I think it would be much better to have some hard-coded rules, some hard-coded grammar rules, and just generate phrases that and substitute synonyms and substitute the appropriate synonyms. There's a lot of better ways to do this than LLMs, but LLMs are cheap and easy, so they're using it for now. And complicated situation. So it's not just a diet that it's seen 1,000 diet problems, but it's Amy said this about me to Joe, and then Joe did this to me, and it really made me feel bad, made me feel shame or whatever. That's going to be really hard for the LLM to reason about that chain of logic in your statement. It'll get the name Joe right and wrong. That's one of the interesting things about like math word problems. You substitute the names in the word problem, and it will reduce the accuracy of the model because they've trained on that test set. They've cheated. They have trained on GSM-8K, this 8,000 word math word problems question. You change the names of the people, which has zero impact, or the names of the object, apples to oranges, and it will get it more incorrect when you do that. That tells you that it's not actually doing any logic about objects in the real world. It's not doing that. And of course, if you change the numbers, especially if you add a digit to the numbers, it gets the math completely wrong. It can only do low digit numbers because there's fewer of them, and it's seen more of them on the internet. And so it's seen that pattern that 1 + 1 = 2, but a lot, but it hasn't seen 5 million plus 356 very often at all. Yes?
As it's being developed, this tool is being used already in those programs that you mentioned?
The professor who is in charge of this course is teaching the course in therapy. And yes, he is telling his students, hey, I'd like you to test out this program. We're working on it together. Research assistants are helping him. Yes, as part of